So let's go ahead and drop down that wedge node, tab wedge, and wire it into the geometry node. What the wedge node does is it allows you to run the same chain or the same simulation multiple times. And the amount of times it runs is defined by ourselves. That's what we have to set up. And while doing this, we're going to be changing one parameter once for every city block. So starting with city block 0 and ending with city block 69. Let's go ahead and set that up. Also, before we forget, let's change this name to city_block output. We're going to use this in the code later, so we have to make sure that we can actually recall this. Now let's set up the wedge. The first thing we change is we are going to turn off random samples because we don't want random samples. We want sample 0 to sample 69 and all of them. And we also want to change that one parameter that changes the city blocks for us on the blast node that we've created just earlier. So we set wedge parameters to 1, and here we're going to have to give it the name and the channel that we're going to be calling. So if you remember it, we had a channel called blocknum. So that's where we're going to fill in up the top, blocknum, right there. And then the channel is going to be a path to the channel from object level. So obj city blocks, isolate city block, which is that purple blast node that we were using, and then the channel block num. And we want to change that at a range from 0 to 69. And the number of steps we want 70. So just for clarity's sake, let's go to object level again. If we look at the city blocks, this is exactly the parameter that we're setting with that wedge ROP. So every time the chain in the simulation runs, it also changes this city block, and then the Python node in cityblocksim sees the input, understands what kind of block it is, and sets all the other settings accordingly. Let's go back to out. If we look at the geometry ROP again, we see $wedgenum in the output file name again, which is coming from the wedge ROP's wedge number parameter to identify the various iterations. Let's go back up to object level and find our Python node that we have not yet filled in yet. Back into cityblocksim and Python write file. So let's get that set up correctly. So this file is going to be the file we'll be writing to. Let's open up the browser, and mine will be stored inside a materials folder that I have, and I've called it cityblocks.txt. You can see I've made a few old ones here as well to test with. Anyways, this is a blank file that I've just created. In theory, after the code is done, once you've defined the path and a name, it should also create the file automatically if it doesn't exist yet, but I've just created one in advance. Let's expand our code window, and let's write down. So the first line we're going to write down is block file, and that's going to fetch the path of the file that we've selected in our file parameter. So block file is who.node, and we can just do a dot in between quotation marks to signify this node, .parm, and what parm is that? The file parm. And then we want to do .eval, so that it evaluates the value that's inside that parameter. Block file path is who.node, and what node is that? That is going to be the city block output node, the geometry node that we've just created on the out network. So we're going to open and close quotation marks, and we're going to go /out instead of obj for a change, /city block output, and that's the one we want. And then on there, we're going to go .parm, and then we have a parameter on there, which is called sopoutput.eval. And if we look at our out network, we can see that we have sop output, and that's the one we want to save inside the file that we're writing, so we can easily pull it back in later. Let's go back to object, find our cityblocksim, and continue writing the code. I'll expand the window as much as I can. So now what's going to happen is we're going to write to the file that we're storing in block file, which is exactly this. And what we want to store is the block file path, which we're pulling in here. Now let's do that. So first we're going to make a file variable. File is open, and we want to convert that to a string, block file. I'll explain in a moment what it actually does, and we're going to set the mode to A. Let's make sure that we write open instead of open. That should do. Now this A here is really important. This is the file mode. We're using append, which is A, because every time the chain runs, what it's going to do is it's going to write another line to that file. If we would use write, for example, it will simply overwrite the file. So if we use a W, instead of 70 lines at the end, once all the blocks have been simulated, we'd only have one final file path. Whereas this way, for every block, it writes the line, and then it looks at the file again once it opens it, and then writes the new file path of the new block underneath the already existing line. This way we get a file with all the 70 blocks inside it. So that's the file and the mode. After we open it, now we just have to write to it. So we do file.write, and we want to write to it the block file path. And again, as a safeguard, I just want to make sure that this will always be a string value. Should already be, but better safe than sorry. And make sure that in between here we simply add a blank line as well. And a blank line can be defined as /n. And I'm appending the blank lines because if I don't do it, it's going to simply add string to string to string. So we're going to get one really long line, and we can easily filter for blank lines later on. File.close, otherwise it remains open in memory. And now every time this chain that we've built up runs, it's going to open the file, write to it, close it, etc. And in theory, we are now ready to simulate the entire chain 70 times over. Let's visualize the final city block point cloud. That gives us our point cloud again. And I'm going to make all these windows their normal size again. Let's jump back up object level into our city blocks node. And on our transform 1, let's set the uniform scale to 20. The only reason I'm doing that is because I figured that the city blocks are a bit small for the buildings that we have, so this way we'll be able to fit in more. And now if we run the simulations, we should have a few more commercial buildings fitting on the same city blocks. That's all the changes I've made. So let's have a look at our out network again. Let's just make sure you save your file just in case something breaks. In theory, you should now be able to run the whole thing. On the city block output with the output file, that's where it's going to be saved to. So it's going to be sent to a geo folder, which is not yet created, but once you run the simulation, that will be made. And you will find all the city blocks in there with the $wedge num creating a number for each. And it's going to be storing the path into the file that we're writing to from the Python that we just created. Let's test that. Select the wedge prop. Go ahead and hit render wedges, and when that's all done, I will see you in the next clip and take up from there.